An MCQ from coordination compounds. A solution containing 2.665 gram of CrCl3.6H2O is passed through a cation exchanger. The chloride ions obtained in solution were treated with excess of AgNO3 to give 2.87 gram of AgCl. The structure of the compound will be. We are given 4 options also. So it is said a solution containing 2.665 grams of CrCl3.6H2O is passed through a cation exchanger. So how many moles of CrCl3.6H2O is present there? So we can write number of moles of CrCl3.6H2O present. We can do that, find that by dividing the weight in grams given by the molar mass of CrCl3.6H2O. Weight in grams is 2.665 divided by molar mass of CrCl3.6H2O. I have found that here molar mass of chromium is 52, for chlorine it is 35.5 into 3, and for water molecule it is 18 into 6. So 266.5. So 2.665 divided by 266.5. We can alter the decimals and see that it will be 0.01 mole of CrCl3.6H2O is present. Now, the chloride ions obtained in solution were treated with excess of AgNO3 to give 2.87 grams of AgCl. So let us find how many moles of AgCl are produced. Number of moles of AgCl, silver chloride, equals weight in grams obtained is 2.87 gram of AgCl is obtained, 2.87 divided by the molar mass of AgCl. Silver molar mass is 108 and for chlorine it is 35.5, total 143.5. On calculating we will get it as 0.02. So 1 mole, we can say that 1 mole of CrCl3.6H2O is giving 2 moles of AgCl. 1 mole CrCl3.6H2O is giving 2 moles of AgCl. Now, 1 mole of chloride ions should react with 1 mole of AgNO3 to produce 1 mole of AgCl. That means there are only 2 chloride ions outside the coordination sphere. Only the chloride ions outside the coordination sphere will react with AgNO3. So out of the 3 chloride ions, 2 are outside the coordination sphere and 1 is inside the coordination sphere. Because 1 mole of CrCl3.6H2O is giving 2 moles of AgCl. 1 mole, if there were 3 moles of Cl3 present, Cl minus present, it would have given 3 moles of AgCl. But we have got only 2 moles of, we are getting only 2 moles of AgCl. That means 2 chloride ions are outside the coordination sphere and 1 is inside the coordination sphere. Let us see how to make the structure of the compound. chromium is the central metal atom. Now, typically, chromium's coordination number is 6. So, chromium can have 6 ligands inside its coordination sphere. Say here, chromium is having 6 ligands inside the coordination sphere, but 3 chloride ions are outside. So, if this was the structure, we would have got 3 moles of AgCl in the experiment. And here, no chloride ions are outside. So, this is also not the structure. What about here? Here, 2 chloride ions are inside the coordination sphere and 1 is outside. But in this structure, we have 2 chloride ions outside. And the coordination number of chromium is correct. So let us see, say chromium, and we'll put 1 chloride ion inside, then H2O 5 times. So coordination number is correct. And then 2 chloride ions outside, and now here is only 5 water molecules, but in the question it is given 6 H2O. So we can put 1 H2O outside. So the structure of the compound can be this. That is option B. CrH2O5 times Cl, that much inside the coordination sphere, and Cl2 H2O outside.